All right, I know you're super excited and ready to do some pressure conversions, so let's get after it here. On the screen, you see some pressure units. We talked about those in the pressure video. These pressure units, and especially the atmospheric values, are what we're going to use to do our pressure conversions. We're going to end up setting these up like we do mole conversions and using dimensional analysis. That's just the way we're going to do it. It's consistent with the way we do everything else. But really, honestly, all we're doing here are proportions. So let me show you a little example of how this works out. Let's just say that I have a ratio here. 1 atmosphere is to 760 millimeters of mercury, as 8 atmospheres is to what in millimeters of mercury? So if we solve for x, we would get x equals 8 times 760 divided by 1, and we would find out that it gives me 6,080 millimeters of mercury. So we could do it that way, and that's all we are. It's just like an English analogy or a math proportion. We're going to even make it nastier with chemistry dimensional analysis. In the first example that you see here, convert 2.5 atmospheres to psi. I start with 2.5 atmospheres. So when I use my dimensional analysis, remember we always want the unit that's going to cancel to go on the bottom, on the opposite side. And I know that many of you, because your teachers do it this way, may see it like that. And whatever unit you're looking for goes on top. We teach it this way because if you would just use the dimensional analysis process, you always get the numbers in the right place. If the units are in the right place, then the numbers should be in the right place. And of course, then we multiply and get 36.75 psi. And those of you who are hung up on sig figs, yes, I should have rounded that to 37. In example 2, we're going to convert 800 millimeters of mercury to pascals. Look how I set it up. Millimeters of mercury cancels. We use the atmospheric millimeters of mercury. And then we're going to pascals, so I put in the atmospheric value for pascals, and we get 8.08 times 10 to the 7th. And yes, once again, sig fig police, 8 times 10 to the 7th pascals. So can you see how that does the same thing as the proportions that I showed you? The conversion factor is actually that atmospheric proportion, the first part of it that I showed you up here. So we're just doing some very simple math for you, but again, allowing the dimensional analysis process give you a framework to help you through. So just some real quick practice here. We do have some metric and we do have some cross units, like English to metric, cross system, that's the word I was looking for. But in number 1 here, we have a metric unit, and we're starting with 225 kilopascals. If I want to go to pascals, we've learned way back in the first semester that that is 3 steps to the right from kilo to base. So that's a 1, 2, 3. Put the eggs in the basket. So we're going to have 225,000 pascals. Number 2 is something you might hear on the news. 960 millibars, maybe as a hurricane's coming through. How many bars would that be? Well, we have 960. Milli is to the right of base. If we're going to bar, that would be base. So we're going to go 3 steps to the left. 1, 2, 3. So our new unit is 0.96 bar. Number 3, we can use our dimensional analysis process. How many millimeters of mercury? So we're going to have 55 psi. So our units will be psi on bottom, millimeter of mercury on top. And now we go to our chart. If you don't have these memorized yet, go to the chart. millimeters of mercury at atmospheric is 760, psi is 14.7, and now we just need to do the math. 55 times 760, divide that by 14.7. Rounding to the proper number of sig figs, you get 2,800 millimeters of mercury. Another similar problem in number 4. 1.2 atmospheres. We want to go to pascals. Well, atmospheres will go on bottom. Back to the chart to get our values. 1 atmosphere is 1.01 10 to the 5th pascals. Again, rounding to the number of sig figs, 1.2 times 10 to the 5th pascals. Pretty easy stuff, right? In number 5, we have 600 millimeters of mercury. How many atmospheres would that be? So there's our conversion factor with the units. We know that 1 atmosphere is 760. So rounding to sig figs, that gives me 0.8 atmospheres. How about number 6? How many torr are in 1600 millimeters of mercury? Work that one out real quick. Okay, you should be done because real quick you should learn that these two are approximately equal units. So they are about the same. And that would be exactly the same. I meant to write torr there. So there we go. Number 7, most car tires hold 28 psi. How many atmospheres is that? So psi on bottom, atmospheres on top. 14.7 psi is equivalent to 1 atmosphere. So rounding to the proper number of sig figs, get about 1.9 atmospheres. So roughly when you air your tire, most car tires now on your normal vehicles are about 28 psi. That's actually a gauge pressure. If you want to take this a little further and learn the difference between gauge pressure and absolute pressure, then I invite you to look those two terms up. Number 8, according to the barometer, a hurricane has a central pressure of 950 millibars. How many bars will that be? Well, we've already seen to just move the decimal. That would be 0.95 bars. How many atmospheres will that be? 0.95 bar. We'll put bar on bottom, atmosphere on top. They are about the same unit. Okay, so that was another sort of trick question. It's about the same. A bar and an atmosphere are a lot further apart. Now, they're both pretty close, but it's a lot further apart than a millimeter of mercury and a torr. But we don't use bar enough to really worry about it. All right, number 9. A manometer shows a pressure of 560 kilopascals. How many pascals will that be? We've already reviewed how to change that. How many psi does that equal? Work that one out on your own real quick. Hit pause if you need to. Okay, if you work that out, you're going to get 82 psi rounding to the proper number of sig figs. Okay, number 10 is a couple of equations. 10 and 11 are a couple of problems where I want you to use P equals FA for a little enrichment. We won't be seeing a lot of that on the tests and quizzes, but maybe as a bonus or an extra question. Calculate the force exerted on a 0.15 square meter plate if the pressure is given. Well, this is P, this is A. So we can see from our equation, if we take P and multiply it times A, we can get the force. So let's do that into the calculator, and it comes out to be 3.8 times 10 to the 5th newtons, which is the SI unit for force. And if we plug in all SI units, meter squared, Pascal, then we'll get the SI unit back. Number 11 is a ridiculous problem, not only because they have a one-legged person, but because the numbers are just unrealistic, but hey, I made it up. I gave it a shot. Pete has only one leg. His footprint has an approximate area of 0.031 meters squared. You can see Pete has a mass of 75 kilograms. What is the pressure that he exerts on the floor? Well, all of his mass and weight are going to be applied to only that area, as he has only one leg, 1 foot. So to calculate that, we know that P equals FA. But first, we have to figure out what F is. Now, some of you who haven't had physics yet, this is the hard part, because you don't know how to find a force from a mass. This is Newton's second law, F equals ma. And when we're talking about weight, we're using the acceleration of gravity. So for this problem, it's 75 kilograms. And the acceleration of gravity, which I think many of you probably heard somewhere before, 9.81 meters per second squared. Pete has a force, or weight, equal to 736 newtons. Well, once we know that, we can go back now and calculate the pressure. 736 newtons over that tiny area. He must have a very small foot on top of only having 1 foot. And it gives a ridiculous 2.4 times 10 to the 4th Pascal. Why is that ridiculous? How do I know right away? Well, if you understand what we're talking about, you recognize that is less than atmospheric pressure in Pascal. So likely Pete would just float away. Or he would be crushed. Oh well, poor Pete. Anyway, the problem wants us to go into PSI, so just for fun, convert that to PSI. Hit pause if you need to. If you did your conversion correct, you get 3.5 PSI. Again, a ridiculous number. I tried. All right, converting pressure units is something you have to do a lot of in chemistry and physics. If you have any questions, come by and see me. Let's work it out.